Good morning, everyone. Thank you guys for coming. I hope everyone is doing really well and having a good day so far. My name is Scott Sugden. I am Product and Technology Outreach Manager here at L-Acoustics, and I'm glad you guys could join us today. We're going to be talking and going over all about M1. Specifically, we're going to go into how to operate M1, how to interface with M1, and what M1 is about. Give me just a second here while I load up my PowerPoint for you guys. And voila. So welcome, thanks for coming. Today is the overview of M1, but before we get started on the overview of M1, I do want to introduce my amazing team with us all around the world. Let's start by going all the way as far east as we can. I think that is Martin Rode in Berlin. Martin, how are you doing today?
I'm good today. Everything's fine here, and I hope you're doing well. Well.
I am. Thank you, Martin. Martin will be helping out moderating questions. If you guys have any questions about M1, please don't hesitate to reach out to Martin. Martin will answer questions in English, German, anything else. Martin, is that the only two languages you speak?
Unfortunately, yes. Only two languages.
Excellent. Well, thank you very much, Martin. Heading to just outside of Lyon, Arno, thank you for joining us. Arno, how are you today, buddy?
Yeah, I'm fine. Hello, everybody. Nice to have you all us with us.
Excellent. Thank you, Arno. And Arno is head of applications for install for France, and will obviously be able to answer those questions about M1 you might have in English and French. Tim McCall is just northeast, I believe, of Arno. Is that correct, Tim? You're just in the foothills of the Alps? Well, Tim is apparently taking a nap at the moment, at least on my end. If we get a chance, we'll go back to Tim at a later time. Tim is joining us as well from the French Alps. Thank you, Tim, for joining us. Heading south of me in Guadalajara, Alex Soto. How are you doing today, Alex?
Hi, Scott. Everything's good. We have a beautiful day today. And well, I'd like to welcome everybody to today's webinar. Buenas tardes, España. Buenos días, Latinoamérica. Hispanos hablantes del mundo, bienvenidos a este webinario del día de hoy, en el cual estaremos hablando de un tema bastante interesante que seguro va a llamar muchísimo su atención. Gracias por estar aquí, bienvenidos, siéntase con la comodidad de hacer sus preguntas en español y aquí trataremos de responderla a la brevedad. Thank you, Scott.
Absolutely, Alex. Thank you very much for joining us today. And just a few kilometers or miles from me right now, Gino, how are you doing, Gino?
Hey, I'm doing all right, Scott. Thanks everybody for joining. Looking forward to this.
Excellent. Well, Gino's going to be as well in the moderation group answering those questions about M1 today. So let's get started today. And this whole week's topics are about system measurement and calibration and about the use of the M1 measurement software. So the big question today is, what is M1? So the concept of M1 is a dual channel FFT measurement platform integrated directly within LA Network Manager 3.0. So what does that get us? If we can integrate the measurement platform into the amplifier control software, it's the combination of two pieces of software you traditionally use, right? So most of the time we end up having a measurement software and a separate piece of amplifier and DSP control software at best. Doing that gives us a lot of really powerful scenarios, but you can run it on whether it's a Windows machine or a Mac. All you need is Windows 7 or greater, or Mac OS X 10.11 or greater. To make this work, we need some L-Acoustics amplified controllers. So this works specifically for L-Acoustics sound systems. We need a P1, and we specifically need that for capturing the data or the measurements themselves. And of course, we need at least one calibration microphone, right? So we need some amplifiers controlling L-Acoustics loudspeaker systems. We need a P1 for capturing the recording or the measurement of the system, and a calibration microphone. So those are the things that are required for this to work. So when we combine these two platforms, we can automate routine functions. So what do I mean by that? Traditionally, when you measure a sound system, you're required to go to one piece of software and mute and unmute different speaker systems and hit the record and capture button, name and label your measurements. By integrating these two pieces of software together, we can simplify that process and automate much of that work. We've also implemented autosolvers to improve complex tasks, so make complex tasks easier to use, and that's aligning mains to subs, aligning mains to front fills, and we can also simplify complex data sets. So I mean that you have many measurements, it's very easy to create an average of many different measurements or a sum of many different things. You don't have to think about all the different possible measurements you take. So let's go ahead and jump right over into M1, into LA Network Manager 3.0. So escape out of there and let's move this over here. Great. So what do I have open for you guys today? I have LA Network Manager 3.0.0.157. This is the latest public beta, which you guys can download from our website. So it's on our website right on the page under software. You can download LA Network Manager 3.0 beta and work along with us in this process. This is the LA Network Manager software. For those of you who have not used it before, it's a pretty simple and intuitive piece of software to help you control your amplifiers, DSP, your processors, and now take system measurements for system tuning. So first and foremost, I'm going to add, I found two different devices on the network. These are the devices behind me. It's an LA12X and a P1 AVB networked audio processor. So I'm just going to add these to my workspace here. And the first things first, this large guy right here is our P1 processor. And I can see real quick that its IP address is IP 100. And if I were to slide this slider down to the bottom, I'll see the full IP address is 192.168.1.100. And I can see that this guy here is an LA12X amplified controller, and its IP address is 192.168.1.101. So pretty straightforward. Some of the things we've done here in LA Network Manager to make your life easy, what we do is we show effectively one main piece of information about the devices on your playground at a time. That's the type, the IP address, the preset that's loaded, the input mode, the output status, routing, so on and so forth. So that really simplifies what you guys are seeing at any given time and makes it easier to use. So these are the first two types of devices, a amplified controller or a processor, okay? And what we can also do is add a group. And a group is what we use to apply EQ or delay or gain to any amplifier channel or processor bus. So in this case, I might call this X8, as I'm using an X8 back here. And I might make another group and call it 5XT, as I have a 5XT for my front fill, if you will. And SIVA sub, if I can type right today. There we go. As my PA has an X8 and a SIVA sub today. So we can add channels to this X8 group just by selecting the output number 1, which I've pre-programmed to be an X8 preset. Same thing, the SIVA sub is going to be output number 3. We can apply that as well. And 5XT happens to be on output number 2. So we use a group for anything we want to mute, anything we want to gain, delay, change the polarity, EQ. We're also going to use groups for anything we might want to measure. So if we want to take a measurement of a specific part of our sound system, it needs to have its own discrete group. We can also have additional groups, for instance, a parent group for something like the all or maybe the mains. So in this case, we'll make an all group, and that was not what I wanted to do. There we go. The mains group here as well, so we could do mains of X8 and SIVA sub, and we could do the all group of all 3 of the speakers. So that gives us the ability to have a group for everything for muting and unmuting for the all group, for example, or just delaying the mains back to the front fill. Those are the different scenarios we could think about. The last thing and the newest member of the LA Network Manager Playground is the measurement location. So the measurement location is what we use to define a place where we're going to put a measurement microphone. So you could think of that as front of house. I want to make a measurement at front of house. I might also want to make a measurement near the front fill, and maybe I want a measurement in the middle. So between those positions. So we might define several measurement locations, and there's no limit to the number of measurement locations you wish to have. So if you would like to have 3 measurement locations or 30, either way is just fine. What you want to do though is give yourself an objective or goal in the beginning of what you would like to calibrate or what you'd like to take measurements of. So in this case, to assign these is just as simple as assigning groups to channels. Instead, this time we're assigning a group to a location. So I'm just going to touch these guys here. So for this particular location, I want to take a measurement of my X8, my CEVA sub, and my 5XT. And same thing here. And same thing there. In fact, let's just take that one out. There we go. So now what we've said is that the X8 is going to be measured at these 3 locations, and the X8 group happens to be controlling the amp channel number 1 of this LA12X. The CEVA sub is going to be measured at these 3 locations, and it's amp channel 3, and the 5XT is going to be measured at these 2 locations, and it's amp channel 2. All right, so right now we've got our unit, the amplified controller, the LA12X, programmed with the right preset. We've got our groups programmed as we want to for our show or our event. We've added our locations for the places we wish to take measurements of our sound system. The last thing we have to do is just ensure that the 2 devices are talking. In this case, I've actually patched them with, I'm going to patch them with AVB. So I'm connecting this amplifier to the P1, and right now output stream channels are going to be from the P1 1, 2, 3, 4 routed to A, B, C, and D respectively. And on the P1, I just want to make sure it's set up. Here we go. Let's do that. And the last thing I want to do is make sure that fan and power is on for these 2 microphones. That's great. We can actually see the level right now because the microphone is, I can talk into it. There we go. I'm going to tap on it. It's all good. And I think we're all done with setup mode. So one of the nice things about LA Network Manager is it's organized into these 3 main steps: setup, tuning, and live. So in setup mode, we do the things like configure our presets, set up our groups, our locations. And once we've done all that, we can move on to tuning stage, or the tuning page. And in tuning, we can start by checking our sound system. If we wanted to with pink noise, we could right away play some music if that's what we want to do. But I actually prefer, once everything is known to be working, to go into M1 pretty quickly. So M1 is launched on the sidebar here. There's a button that says M1. And this is working in every version of LA Network Manager 3.0 beta. So if you have one of the betas, please feel free to download, install that, and here's how you can launch M1. And the first thing M1 does is take you into the record page, or the record tab. So in the record tab, it's a basic, or in M1, it's a basic 3-step process. Step 1 is we want to acquire the data that we're going to use to then analyze for equalization and alignment. And what M1 does is automates a lot of these aspects of workflow. In this case, we have the front fill location, we have the front of house location, and we have the mid location. So we have 3 possible locations we've defined. We have a list of inputs on the P1 we wish to use. So at any of these locations, you can assign any of the 4 inputs on the P1. So in this case, I could make the front fill, the front of house, or the mid mic 1, or I could set any of them to be mic input 2. The second thing we have on top here are the list of measurement groups, or groups that we wish to take a measurement of. In this case, it was the 5XT, the CEVA sub, and the X8. For each of these, you have a choice of some settings of your system record. So things we can do, for instance, are set the number of sweeps, and then we're going to listen to this in a second, but what M1 uses is an impulse sweep versus pink noise. We can have it do 1 to 10 different sweeps. And real simply, if you're indoor and you're close range, 1 works just fine. If you want to check to make sure there's not too much variability, you can set that to a higher number. We can set the sweep duration, so the longer the sweep, the better our signal to noise ratio, the more energy we're going to be able to capture from the microphone. And we can set the volume of the sweep, so the louder it is, the better our signal to noise ratio is going to be. Let's go ahead and just set a few settings here. And I'm going to place, I've got actually 2 microphones in the room with me right behind me. This is the world's tiniest sound system calibration. Here we go. So we're going to set 2 microphones right behind me. We're going to pretend this is a huge sound system in a giant room at a large show. Instead, it's a X8 and a 5XT. And I'm going to arm the front of house location. And when I arm the front of house location, it automatically selects these points of the matrix, which is the intersection of the front of house location CEVA sub and front of house location X8, and says, let's record those. And since I have 2 microphones and I'm using 2 different preamps, I can arm a second location simultaneously. And M1 is actually going to take care of making a recording of all of this. The last thing we have to do is just tell M1 what is the source of the signal using for the 5XT, what is the source of the signal you're using for the CEVA sub, and what is the source of the signal you're using for the X8. So in this case, all of them are being derived from AVB bus A, which is on output 1 of the P1. We can hit start record, and here we go. All right, so M1 actually took care of all of the muting and unmuting of the different amplifier channels and groups. It also took care of the naming of all of these different measurements, and it's going to help store that data for us and organize that for us so we don't have to do that either. So all of this is taken care of, automated for you, and this works for a very simple sound system like we have here, and it also works for a very complex sound system, a large festival, or an arena tour, or an ELISA sound system. We have multiple different zones, multiple different measurement groups and locations. So I'm just going to expand this window slightly. And what we can actually do is take a look here, for instance, at our 5XT. This is at our mid location. So this is the mid location, the 5XT. And the first thing I see here is a dotted line which represents the signal to noise ratio of the measurement. And I can actually see that SNR measured in dB on the right here. And right now, we actually have well and above of about 45 dB of signal to noise. That's really good. And here's my actual measurement that we took of this particular 5XT that's directly behind me. And there's another way I can tell if this is a good measurement or not. This is called the quality bar, and this indicates to us whether the measurement's good. And as long as you have a greater than 20 dB signal to noise, this bar is green. So the goal here is to see green throughout the entire operating bandwidth of the 5XT, and that's exactly what we see. We can also see each of the individual 4 measurements. We could turn any of those on or off and add them to the scenario, the calculated score here. And what we can see is they're all pretty much identical. So all of these are the same. That makes sense. We measured inside at about 2 or 3 meters away. I would not expect a huge difference. So I can approve this and say this looks good. It's very quality. And by hitting the green checkbox, it puts it into the database. So we can go here and check the CEVA sub, and this is at the front of house location or the mid location. That's kind of neat. All right, so all looks good. Quality is really high, so let's go ahead and accept that. Same thing for our mid location. Everything looks really good. The quality bar is great all the way through the operating bandwidth. And let's check our X8. Same thing here. Quality is really good. The signal noise ratio is really good on both these. That's not a huge surprise as we're indoor, we're close. I wouldn't expect a huge issue. So that means we've just really quickly, with just a couple of mouse clicks and without having to manually mute and unmute parts of our sound system and name different components, we've done 5 different points of our matrix in measurement in just a few seconds. We can then arm our last location, and notice by arming my last location, mic number 1 is automatically unarming any other places where it's selected because it's got the same mic set. So let's unarm that. And I'm just going to change this to the number of sweeps of 1 because we don't need to have 4 sweeps we've learned. And mic 1, move it somewhere new. That's a new spot. And I'm going to hit start record one more time. This should be pretty quick. All right, so once again, great signal to noise in the dotted line there. Here's our actual measurement, and quality bar indicates that it's a really good measurement, so we can improve that one. The sub quality bar without its throughout its operating bandwidth is very solid. Signal to noise is almost above 45 dB the entire time. That's great. And last and not least, my front fill, or sorry, my main PA, I was really close, so the signal noise got better, and that's really good as well. So we've actually got all the data we need now to do all of our system tuning. And the neat thing about this is the rest of the time, our sound system can actually stay muted. And part of that is through the concept and process of M1. All of the equalization, gain, and delay is actually all done in post-processing. And so if you want to think of this in a couple of different ways, one way I like to think of it is we're able to actually see the entire city map. We're able to see the entire evolutionary tree at one time and decide which branch we want to go down. Meaning we can change our course without having to redo all of these steps, figure out all of these things along the way, and retake a bunch of measurements. So in the EQ page here, we have a matrix of the locations, front of house, front fill, and mid, and we have a list of the groups we measured. So I can real quickly and easily see the response of this one X8 measurement in my window here. I can see multiple responses. So these are the 3 different locations. That's great. They look quite stable. I can change the smoothing I wish to see. And I can also really quickly generate an average just by selecting this average of all button on the bottom. And what this allows me to do is create an average of all 3 locations for this particular source. So all 3 of these are averaged together, and now we can start to see something that's quite interesting, right? So here's the individuals, and that's the average. We can do the same thing for the SIVA sub. So we can create an average or see the individual measurements. And same thing for my front fill. Here's my front fill of the 2 different locations we measured it at, and here is the individual measurements. The second thing we can do is for any given location, we can add up all the different sources that we measured at that location. And so, for instance, I have the SIVA sub and the X8. If I turn on the sum and I hit the sum of the 2, this is the sum of the 2 as the DSP is currently set at this given location. And we can do that across multiple locations as well. So I can say, see this average, add all of these to the sum, and display the average of sums of all 3 of these as well. So all of that can be done. We don't have to take additional measurements. We don't have to do any programming. It's just simply selecting. Up on top here, we have the different groups we measured. So remember, we measured the 5XT, we measured the X8, and we measured the SIVA sub. So those are the 3 different groups. And we also created 2 additional groups for control, which were mains and all. So on the X8, for instance, we can take a look and decide that we don't like this extra energy at 1800 hertz. What I can simply do is add an EQ at 1800 hertz and set it to be minus 3 dB. And M1 actually allows me to see the response of the EQ without having to take an additional measurement. Pretty neat. What's also possible here is we could change the delay, and so we could try to figure out how to align these, because it looks like we have an alignment issue currently between our X8 and our CEVA sub. And I'm not exactly sure what we should do, but we could start trying to find the best delay. It might be the one. And this would be one approach, is to just go ahead and put in some information, but we think we have a better solution, right? And the better solution would be to use the auto align tab. And this is the third step within the M1 software. So step number 1 was record the data. Step 2, we can take a look at the EQ, change gain of different groups or measurements sets. And then step 3 is auto align. So let's go ahead and go into auto align. Let's take a look at front of house location. Front of house location, we see that it gives us the ability to see the CEVA sub and the X8. So by selecting X8, I can choose where I would like to apply my alignment values. It could be in the group all, or mains, or X8. If I apply to the group mains, what the software is going to actually do is automatically gray out the CEVA subgroup, because they're both in the same group. So it's going to be impossible to align two different things using something that controls them both. That's not going to work. So that's going to be really hard to do, is to get those two to align when we're moving both of them with that same group. So instead, what I want to do is apply the X8 to the X8 group, the CEVA sub to the CEVA subgroup. And we can take a quick look down here. And what we end up with is a graph of the two and the summation. But more importantly, we have a really cool tool called AutoAlign here, which is going to help us find the best alignment between the two of these. And the way it does that is it takes a look at the summation of the response, it takes a look at the phase response and the impulse time all together, and uses an algorithm to help find that alignment between these two. We give you guys some indicators. It's really obvious to see they're not aligned because of the summation. That's the dark line here below the two others. We also get a quality bar indicator that gives us an indication of the quality of the summation. We can change the smoothing so we can really see the problem here at 100 Hertz is not looking very good. And simply to use AutoAlign is as simple as clicking on 1, 2, or 3. So it gives us 3 possible alignment scenarios. Clicking on number 1 suggests we invert the polarity of the CEVA sub and add 0.06 milliseconds. So in actuality, let's go back to 0 here. I put that back to 0 time. Voila, great. The best alignment is effectively, we don't need time, we just need to change the polarity of the CEVA sub. We could look at the other two options to see if they're better. In that case, it's suggesting to put 4.5 milliseconds on the X8, or option number 3, which applies a whole lot of time to the CEVA sub. So this case, this makes a lot of sense to me for this particular value. We could look at the impulse response as well and see the energy arriving. And that looks pretty good for starters. And we could even look at the phase response if desired as well. So all of that's possible with an M1 AutoAlign. What's really neat about this, though, is if I flip that polarity back, we can see that the alignment is not very good right now between, say, 50 Hertz and about 150 Hertz. And that makes sense because that's the bandwidth at which these two groups are actually overlapping. So we can see that their main frequency of overlap is somewhere between 50 Hertz and 150 Hertz, and we're having some challenges in alignment there. This quality bar is also rendered for every other location where these two groups were recorded. So we actually see the same quality bar rendered at the front fill position and the mid position. And the neat thing about this is I can really quickly and easily tell if the alignment choice I'm making at one position is a good choice for many positions or all positions. So let's put that back. So now this is a really good choice for the front of house position, but we can also see it's a really good choice for the mid position and the front fill. So that's quite nice. So that works really well for aligning, say, your mains to your subs. You can also use AutoAlign to align, for instance, your mains to your front fills. So in this case, let's select the X8, but this time let's go ahead and apply our settings to the group mains and 5XT. So we're going to shift the group mains, which contains both the X8 and the CEVA sub. So that way, when I shift and add delay or polarity changes, it does it to both. and then the group 5xt for the 5xt. So same thing, AutoAlign will help us find the best alignment value, and it's proposing we put about 5 milliseconds on our 5xt group. We could change the gain here to get them a little closer together if we wanted to. We can see that the gain of the two is adding up really nicely, and that makes sense as they have a good alignment at that particular position. So we have a little challenge here down at the very low end. That's probably not a huge concern for us when we're talking about mains to front fills, but otherwise across the rest of the operating bandwidth, we have a really consistent summation quality and a really good alignment. And once again, if we looked at the impulse response to see when the energy arrived, they're probably really close to each other, and we can see that as well. The two colors were slightly different. There we go. We can see they're right on top of each other. That's really great. We can see at the mid position, it's a bit more challenged, and that makes sense because it was further back in the venue. We're going to have a different time of flight. In this case, our venue was very small, and our two microphone locations were only a meter apart, so it's not a huge difference. But with front fills, we often only get the choice to align it as best we can in one particular location. So all of that can be done within AutoAlign. And if we wanted, we could link these together and apply an additional 2 milliseconds to one group or the other, and push everything back together as well. So what's neat about this is we've now done our alignment. If we need to go back and do a little final EQ. So this is our overall response. I'm not so happy with this bump at 7 kilohertz or so. Maybe I can use this FIR on the X8 group and minus 1 dB, minus 1.5. Great. Looks pretty good. Change our smoothing to see if it still looks pretty good overall. I'm really happy with this. We could see what our front fill does up front here and add that in. Oh, look at that. The energy's really great there. We can even see the response of the front fill. Within the EQ page, we can once again adjust the gain and delay of different things. So we could turn the gain down of this by 1 dB. And all of these settings are here just like they were on AutoAlign. In fact, all of these settings are also back on the LA Network Manager Playground. They're actually synchronized the instant you do it. So as soon as you modify something within M1, that setting is implemented in real time into the sound system, the amplify controllers that are connected. And this is bidirectional. So what's really powerful about this is in the middle of the show, if you are mixing an event and you realize, you know what, on this X8 or the main system, there's just a little bit too much 250 hertz, maybe the audience has changed the way it sounds, I can pull some of that out. If by chance I go back into M1, I can see the effect of that EQ on the mains, and I can see what it's done to our transfer function. Oh, I see it. Maybe my problem wasn't at 250. Maybe my problem was more like 310 hertz. Maybe it was that bump that was bothering me. So this is all bidirectional from within LA Network Manager for the workspace of LA Network Manager to the interface of M1, the measurement portion of the software. So we now have the ability to tune the system silently, which is a really powerful feature, which means the first time you make noise out of your sound system, it should be aligned and equalized, and everyone's going to hear something that sounds really quite well put together, which is a really good thing for systems engineers, for front of house engineers, for bands, and for producers and promoters. During the show, however, we now are operating. We have these 4 great mic preamps on the P1 processor. With those 4 great mic preamps on the processor, we can also launch the RTA. So M1 comes as well with an RTA, and this is really neat as we made it a separate window. So within LA Network Manager, we launched the RTA, and we can launch this into a separate window. We can use a mic calibrator. So real simply, I'll put a mic calibrator on one of my 2 microphones. Should be pretty obvious which one it is here in a second. Okay, so this is mic number 2. And to calibrate this, I just need to hit the calibrate function. And here we go. Okay, so that's calibrated, and we can send that to the meter, and we're getting 94.1 dB. It's pretty darn close calibration. We could try it again to get it a little closer if we needed to, but for today, I think that's fine. And so now we have a calibrated RTA mic, and if you want on your event or your show, if you have 2 screens, I'll often put this RTA window on a second monitor off to the side in front of the front of house engineer, so they can watch the the system response in real time. So guys, that is M1 overview to start this week out. Tomorrow we have a presentation on a basic system calibration workflow. It's going to be a case study from Alex, who's our product specialist specifically for M1. On Wednesday, we have a presentation a bit deeper into the workflow of calibration, another case study on Thursday, and on Friday, we have a presentation from our Director of Scientific Outreach, Etienne Cortel, all about the optimal place for measurement locations and how to acquire the best data. Do we have any questions, Tim, coming in? I think we have a couple of them.
Yes, we do. There's a lot of people asking, why don't you auto-align before you EQ?
That is a great question. So the neat thing about M1 is it actually gives you the choice to go either way. There are certain situations when I might do some basic equalization before I do my alignment, and that's because, for instance, if I want to tailor or shape the way the low frequency is, with an IREQ, that will impact the phase response of those individual sources. So very much there are situations where you might want to do some equalization first and then alignment, and there are other situations where you might want to do alignment and then equalization. There are both valid reasons to do either of those, so I wouldn't hesitate to try in either way. The system has no challenge with you going either mode, right? So if you're more used to doing alignment first between two different sources, for instance, here we could align the X8 and the SIVA sub first, and we could set the relative gain between the two and say we want to have an extra 3 dB of energy on that SIVA sub, and then we could check our auto alignment value to see if it still is optimized at that exact time. And notice that as we changed the gain slightly, we actually found a slightly different alignment value, which makes sense, because as we shift the gain of these two sources, we're also shifting their acoustic crossover point, which is going to change where we want to find the best phase relationship between the two of them. So there you go. So either way works just fine. So your preference to which way you would like to go works fine in either way. That was a great question. Another question, I think. Do you have another one for us, Tim?
Yeah. The measurements you captured, do they simulate changes with auto climate? How do those work together?
So, within M1, we can change and post-process anything that we've captured, right? So that works well for measuring an individual source like an X8. It works really well for capturing an entire line source array of like a K2. What is hard to do is post-process or change individual elements within that. So this really leverages into the world of simulation. This is where we go into sound vision. When we're on site, it's hard to, for instance, just change one filter on one enclosure of a multi-enclosure array and see that change in a measurement platform. So that's not something we can do quite easily. The analogy I like to think of is you're making a really amazing dinner and you decided you wished you would have seasoned something that is now in the dinner differently in the very beginning. That's hard to do. You can only change the seasoning of the overall dish. You can't change the seasoning of that one element of the dish after you've baked it. So same thing with an M1. You can only change in post-processing the things that you've measured directly, not their components themselves. But great question. Another question. You got another one here coming in, Tim?
Yeah, it's quite an interesting question.
Yeah.
If you're using the RTA and you've got two P1s, can you send the data from one, so your RTA information from one P1 to another over ABB, or the signal from the microphones? Yeah.
So right now, the measurement platform in M1 is using one P1 as a master, as a primary, and the other ones are not functional within that ecosystem. So that means one is generating the measurement signal for our system tuning software, and that same one is acting as the 4 preamps. The neat thing about all of this is because we're doing everything in post-processing for the system tuning side, if you have 2 or 4 microphones, you can move those 2 or 3 times and end up with 16 locations really quick, which is like having 16 active RTA mics or measurement mics. In terms of RTA for during the show, the one that you set as the master, the one that is the main one for the RTA, is the only one that can be active with the 4 mics. So you can't have, unfortunately, mics from other locations at the moment. Martin, did you end up with anything other questions in German or English that we might be able to answer today about M1?
Not really what we couldn't answer so far.
Great.
There have been some specific questions, mostly in English, which are far beyond the basic level. So,
yeah, no problem. No problem. That's great. So guys, if you do have more questions about how M1 works in a deeper way, each day this week, we're going to build on this topic a bit, and we're going to grow. So today is all about learning the basics of it, how it works. Tomorrow is going to be an application case study to give you an example of how to use it from Alex, and he's going to do a great job with that. And later in the week, we've got a pretty elaborate case study of a real venue with real data, with the design included. So you're really going to understand how we get deeper into this. So please don't hesitate on that. Tim, did you have something else as well?
Yeah, just a very basic question. Maybe some people missed it in your presentation there. Why do we use the sweep and not pink noise?
Sure, that's a great question. I'll answer that a little bit now. I'll answer it a little bit more on Wednesday in more detail. But we can get as good or better data than pink noise with a better signal to noise ratio. And honestly, it's a whole lot less annoying than 2 hours of pink noise. So if we can get the same thing with less annoyance, I don't know who in sound doesn't want that. Pink noise is really therapeutic. Pink noise is really lethargic. I know every one of us in this industry has taken a nap to someone else tuning a sound system with pink noise for 2 hours. One of the neat things is this sweep is much less obtrusive, and so often you can do it while other departments are working. So I often can take measurements while the lighting department is doing their focus, and this doesn't seem to bother them nearly as much. And it doesn't have to be nearly as loud to get the same quality of data. So that's quite nice. Well, I think, Tim, if we haven't fielded any other questions from Alex or Martin or Arno, I think that's it for today. Is that correct, Tim?
Yes, Scott,
yes.
there's an interesting, there is a guy asking why are you using sweep instead of pink noise?
Yeah, I think we just did that one out. You must have just dropped out on us, but the main reason is obviously it gets us as good a data as pink noise, if not better, in terms of signal to noise ratio, and we don't have to do a measurement for as long. And pink noise is just annoying. So those three things combined. But thank you. Tim, one other thing you had, I think, or is that it?
No, I was just going to say, I think that's it. There are a lot of questions, guys. We haven't got time to go through them all, and some of them are definitely going to come up over the next few days as we get more in depth into M1 and using this as part of your tuning of your system. So please come back tomorrow with Alex. Please come back on Wednesday, Thursday, and then on to Friday to understand the whole system.
Thank you, everyone. Thank you, Gino. Thank you, Alex. Thank you, Martin. Thank you, Arno. Guys, I hope everyone out in the world is safe. I hope everyone is healthy. Please do your best to stay that way. We're all really looking forward to getting back to work as much as you are on shows around the world. If you have questions about this specifically, don't hesitate to reach out to us on social media. We have a bunch of great topics. Same time this week. For those of you who noticed, France had daylight savings, so we've adjusted for the French. It'll be this same time this week, and please don't hesitate to reach out. Have a great rest of your time, guys. Thank you very much, and be safe, be healthy. We'll talk to you soon. Cheers.